So this question here is asking us to it's down here and it says calculate an estimate for the acceleration of the car in meters per second after 10 seconds. Now, if it was at 6 seconds, let's say, it would be easy. It would be a lot easier because at 6 seconds, I've got a straight, a constant acceleration. So the velocity is accelerating at a constant rate up till that point. And so it would be something like at 6 seconds, well, first of all, the time. So that would be, yeah, this would be 6 seconds here. And it actually looks like at 6 seconds, the speed, the change in velocity is also 6. So if that was what it was saying, then the acceleration would be equal to the change in velocity, which is 6, divided by the time, which in this case is 6 also. So the acceleration would be 1 meters per second squared. That's if it was 6 seconds, but the problem is it's not, it's 10 seconds. So when it's at 10 seconds, we have to do a similar sort of thing. We have to think, well, the trouble is it's not a straight line. So for that, so it's a curve, in fact, it curves at that point. So they've got asked us to do it on a curve. So what you do is you draw a straight line yourself, and you put it at a tangent to where this point is. Now, I don't know how well that tangent is. It's not too bad, I suppose, but you do it at a tangent to that point. So this stuff here, this is from a previous question, so maybe we can get rid of that just for the moment. Just for these, I'm going to put it back on in a moment because we need it on the whiteboard. But so we can ignore that pink. I'm going to put it back on again now, though, I'm afraid. We don't need to look at that pink. We're just looking at this red line. And we're going to actually work out the gradient of that red line, just like the red line, the red dotted line was the line graph. So we can take any part of that line and draw a triangle. So let's draw it from maybe from there downwards. Okay, so I'm just going to choose my pen. I'm going to choose smart drawing. I'm going to draw it from here all the way. Oh dear, it's not very straight. Let's see if it straightens it up. Awesome. And see if it'll let me move it this time. Thank you, that's good. Okay, and now let's draw another one to here. That's much better. Okay, so we're going to use this purple triangle to calculate the gradient of that part of the curve. So the gradient of that dotted line, which is a tangent to the curve. So we're going up from, let me just, if I can get rid of that thing over there. Good. So it goes from 8 to 14. So so the change in y, oh, let's turn off smart drawing.
Connecting to question B there, but
I'm working out the gradient of this slope. So the change in y is 14 take away 8, which is 6 meters per second, actually, because that's what y is measuring. The change in x is equal to, well, let's just see. We need to zoom out now so we can read the x-axis. So it's 10. Oh no, it's not. So that's 15. Oh, these numbers are quite nice because it's just 1 per little division. So that means that's 18, and this one would be 8. So 8 to 18. So actually the change in x is 10. So 10 seconds. So acceleration is going to equal to the change in is equal to the change in velocity divided by the change in time. In this case, the change in velocity is 6. The change in time is 10. So the acceleration is 0.6 meters per second squared. Let me just write that in GCSE format. That's what it is now. That looks like it's about right, because when we worked out the other one, it was 1 meters per second, and you can see it's got less steep. If we did another tangent around there, it would be a lower value still. So it's a bit weird that I'm doing a gradient of this line that I drew myself, but that's because I'm drawing a gradient to show the angle of that part of the curve. And once I've done that, once I've drawn the angle of that part of the curve, I work out the gradient of the line that I've just drawn. And we call this line that I've just drawn, we call it a tangent. Okay.